is going on? Today we are going to be looking at box and whisker plots. So you might be asking yourself, what on earth is a box and whisker plot? Well, the one thing I can tell you that it's not this. All right, this is not a box and whisker plot. All right, so box and whisker plots is another way to display different types of data. A lot of times, as a middle school student or elementary high school student, you may not see this as much, but when you're comparing two box and whisker plots together, it's much easier to kind of differentiate what's going on with the data that's collected. So it is another way. It's actually not that bad. In years past, I've had students that after we go through some of the lessons and tutorials, it doesn't seem to be that difficult for them. Once again, you want to make sure that you're keeping your numbers in order from smallest to largest. And for the teachers out there watching this, I am also going to provide a link to a cool, easy graphic organizer foldable in the description, so keep an eye out for that. We're going to go through some interpretations and also how to actually plot one out. So make sure that you subscribe, like, comment, and all that will definitely help me out. Otherwise, enjoy. I think you'll have a good time with it. All right, so the first thing we're going to do is we're actually going to make our own box and whisker plot based off of these numbers in this data set. What I will say is that the approach is going to be similar to what it was when we were looking at mean, mode, median, and range, where you want to put your numbers in order from smallest to biggest. It's going to be much easier if you go from smallest to biggest. So staying organized is going to be key. The other thing is that I do want to state that in some cases they may give you a number line already that you can plot right over top, but I want to show you that that's not necessary. As long as you're putting your numbers in order from smallest to biggest. So let's go through here. We'll look for our smallest number, which was 16. Our next number is 19, and we are going to list both of those, right? Just because they repeat, we don't skip out. And then we have, looks like we have 23, and then we have 24, 25, and then we're jumping to 31, 37, 42, 46, and then 47. Okay, and now the first thing we're going to do is we're going to be making our whiskers. All right, we're going to be looking at the ends. So what we're going to do is we're going to draw a little dot here, 16, and then over here, as long as you give yourself enough room, we're going to be putting our other end, which is our 47. All right, so we have those, and then we want to find out what our median number is, which is our middle number. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 numbers here. So that would mean that in order for us to have the same numbers on either side, we're going to go to our sixth number, which in this case is our 25. So we should have 5 numbers here, and then 5 numbers on this side, which we do. So our middle number is 25. So we're going to draw a line like that. All right, you want to make, in some cases, for me, when I'm having these other kids draw it out, if it's drawn out correctly, it really should be distributed over the number line. But as for now, we're not going to use a number line. All right, so that we have our least value, which is this one. We have our greatest value, which is the 47. And then the 25 represents, let's put this guy on top. 25 is here. This is going to be our median, our middle number of the set. All right, now, what we want to look for now is what would represent our first quartile. So that's actually going to be the middle number of this first set here. And since we have an odd amount, we're lucky. So we know that that's going to be our 19. So that's going to represent our 19 here. Right? And then for the second set, well, actually not the second, I should call it the third quartile. We'll discuss that in a minute. It's 42. Okay? And then what we're going to do is actually draw our box and then connect our whiskers. Using a ruler obviously would help. Now, the 19 represents what's called our first quartile. and then this represents our third quartile. So you may be asking yourself, well, how did we go from first to third? Well, guess what? The median is also known as your second. All right, now, in the event that you have an even amount of numbers in the entire set, we're going to do what we did when we found the median before. You would add those two numbers together and then divide by 2. Same thing for our quartiles on the other end. So when you have an odd amount, it's a little bit easier to work with. The other thing I want to talk about, which we'll see in this worksheet that I want to post in a minute, is that no matter how these are drawn, doesn't matter if one part's wider than another part, each of these is going to represent 25%. All right, so we can say that the first 25% scored below 19. The first 50%, or the 50%, scored below a 25, 25, and 25. It makes sense because when you add those all up, it's going to equal 100%. All right, so let's take a look at this worksheet that I have here. It says they want us to answer the questions based on the information below. And what this is stating is that students were tested on the novel The Giver in November. Their scores were displayed in this box and whisker plot. All right, so the plot is the number line and the box and whisker plot is already done for us. So now it's just a matter of interpreting the data. Question 1 says, what is the median of the data set? So median, if you remembered watching my mean mode median video, the median, think of middle, that's your middle number of the entire set. So that's going to be represented right here. All right, so our answer for that one should be 81.5. The next question asks, what is the range of the data in the plot above? Well, since it says data, that's the largest number, which in this case is 100. Subtract it with your lowest number, which is 63. So that answer would have to be 37. All right, so that's going to be B. I also want to stop for a minute and talk about what your interquartile range is. So the range is your entire set. If they were to ask us what the interquartile range, which we see here for number 3, that's taking the ends of your boxes and subtracting them. I find that in my experience that's where the students have some issues with the terminology, so that's definitely something that you have to be aware of. So when you subtract that, you get 19. And notice that both 37 and 19 were options for those because they're anticipating that to be a pretty common mistake with students. All right, number 4 says, what is the attribute being measured? So basically, what are we trying to look at here is what they're saying. So once again, students were tested on the novel The Giver in November. Their scores were displayed in a box and whisker plot. So is it showing us the number of students? No. B, number of tests? Nope. Scores on student tests? Yep, looks like that. And then, or the number of student scores? Well, no, it's got to be C. We're looking at the scores on students' tests, which, a lot of times, you believe it or not, teachers take a look at this when they're seeing what they need to focus on more when they're gathering data. All right, number 5, which of the following could be a statistical question related to this data? So I do have a video entirely devoted to what statistical questions are. Well, by definition, a statistical question is one that can be answered by collecting data, meaning a numerical type of answer, and where there could be a variety in that particular data. So for instance, if I'm asking my kids, how much time do you spend playing games on your phone? I could have one kid say that he spends a half hour a day, or another kid says that he spends 8 hours a day. All right, so the numbers could change, but it's a numerical type of answer that could go up and down. All right, just like that we have here. So which of the following could be a statistical question related to this data? How many hours did the teacher spend making the test? Nope, that's not mentioned at all. What did students score on the test? That's what we have. But let's just go through the rest. How many students are in the class? Nope. Which test did the students take in November? Yeah, it does say that, but we're looking at the numerical data. It has nothing to do with numbers there. So our best fit would be B. And then number 6, what percentage of students scored above a 73? So we're looking at above a 73. So 73 is located right here. Remember, each of these spots represents 25%. No matter how wide or narrow they are, it's still going to be 25%. So you add those all up, 75% of that student population scored above a 73. All right, and then the last one says, 25% of students, so that means it's got to be from here to here, scored below what score? Well, that means that they scored below a 73. All right, easy interpretation. As I said, I'm going to provide a nice little worksheet slash graphic organizer foldable in the description, so keep an eye out for that. It could help you. It has the answer key and everything.